Welcome students. My name is Dr. Praneeth, and today we will see about the last part of this first unit, that is benzene and its derivatives. So let's see today the preparation of the last class. We have talked about DDT, BHC, chloramine, these four compounds. Let's see the uses and preparation of this four compounds. So in last class we have seen the DDT structure uses, right? So today we will see about the preparation, how to make DDT. So DDT can be prepared by the treatment of chloral. So this is the chloral structure. Okay, it contains trichloroaldehyde CHO group, the CHO. So this is a chloral, and treatment with the chlorobenzene. Chlorobenzene, we already know that benzene having one chlorine group, right? So we need two chlorobenzene. So this is why I have written two chlorobenzene. And in this reaction, I have shown one of the hydrogen. Because when this reacts, the water will remove. So this hydrogen and oxygen, H2O, will remove into the to the final product. So let's see what happens. You also need some acid, like this sulfuric acid. So what happens is the water will remove, and this three part will join together to form this DDT structure. This is the DDT structure. This is this dichloro. Okay, diphenyl. So dichloro, that is this one D, and diphenyl is the other D, and trichloro, this trichloroethane. This is the DDT structure. So with this we finish the DDT, the preparation. This is how it is prepared, and we already seen the uses of DDT. DDT is used for as an insecticide, right, to kill the bugs in the agriculture process. So we will now move on to see the second compound in the list. The second compound is called as saccharine. So this is the chemical structure of saccharine. It contains a benzene ring. This is a benzene ring, and attached to this CONH. This is the amide CONH, and then SO2. This is the complete chemical structure of saccharine. So what is saccharine? Saccharine is very familiar to all of us because it's an artificial sweetener, right? Especially this is used for diabetic patients, because diabetic patient cannot, the sucrose level will increase. So alternate for sucrose, we will use saccharine as the artificial for sweetening any beverages, whatever. So that's why the main use of saccharine comes from as an artificial sweetener. It's actually is 300 to 400 times more sweet than the sucrose. The sucrose is already sweet, so it is, you can see the effective sweetening capacity of the saccharine. It is 300 to 400 times more sweet than sucrose. As I said before, it can be used as an artificial sweetener in drinks, in beverages like Coca-Cola, Pepsi, etc., coffee, and used in candies, cookies, and also in medicine. Sometimes we need to add some sweetener in the medicine. The chemical taste is very bitter, very difficult to consume. We will add some sweetener, right? So for that, saccharine can be used as a sweetener in the medicine also. So these are the three the points I mentioned for saccharine. Let's see the physical properties of saccharine. So saccharine is a colorless and it's a white crystal. So it's a colorless or a crystal or powder. Okay, it can be available in crystal or in powder. So if we crush, it will become powder. So this is the image of the saccharine. You can see that it is a very tiny crystal or powder type. Saccharine. As I said before, the physical property is one of the tastes. Physical properties, it has intense sweet taste, and very importantly, it is very stable to heat. So you can store in out at home. Don't have to keep it in the fridge. So it is stable to eat, so it is not decompose, right? And also important property, another important property of the saccharine is it doesn't react with any food ingredients, other food ingredients. So if you consume the, for example, if you add the saccharine into the Coca-Cola or coffee, so this saccharine will not interact with caffeine, right? Caffeine is an ingredient present in the coffees. It will not interact with cocoa or caffeine. So it's a important property of saccharines we can use in the beverages and other food products to make it sweet. Again, the uses of saccharine is substitute for sugar, right? It's a substitute for sugar, used as a beverage, sweetener in beverages, also in chewing gums also can be used for sweetening purpose, and also used for sweetening in the vitamin supplements, because vitamins are sour, so add this saccharine to make it consumable, and as I mentioned before, can be used as sweetener in the medicine also. So now let's move on to see this how we can prepare the saccharine. How to prepare saccharine? This is the one of the sugar substitute picture. So you see the calorie is 0 calorie for this saccharine. So that is another important property. It is no calorie. So if you are calorie conscious, this sugar substitute is important for you to lose weight or etc. So now let's see the synthesis, how to prepare saccharine. So this is a multi-step process. To prepare saccharine is not one step, it is a multi-step process. So here I have given the chemical steps involved to make the saccharine. So you start with this methyl benzene, it is also called as toluene. Okay, it's also called as toluene. So it's a methyl benzene. On treatment with chlorosulfonic acid, you will get toluene sulfonyl chloride. So this is a toluene and sulfonyl SO3Cl. Sulfonyl chloride we will obtain. Okay, and then this on treatment with ammonia will give the toluene sulfonamide. Toluene sulfonamide will be produced. Okay, plus hydrochloric acid. So this already one step. This first product toluene sulfonyl chloride, this on treatment with ammonia, ammonia will replace it, right? Ammonia attack here and then HCl will form. A chloride is removed from this, from here, and then one hydrogen is removed to form the HCl. So this is the second step. Already two steps are over, and in the last step is the oxidation process. So basically it combines here, these two will combine. So this CH3 and SO2 NH will combine. The oxidation means addition of oxygen, right? The one of the oxygen is added here in the carbon. You see here, this carbon, this is a new oxygen. So that is oxidation. So you will get the cycle ring will form here, the 5-membered ring, 1, 2, 3, 4, 5-membered ring form here. This is called as saccharine. This is structure of saccharine. It is written, drawn in this way, but it can also, if you turn around, you will get this same structure you have seen previously. So it is still the same structure. It's called as saccharine. So how to prepare saccharine? It's a multi-step process. It involves, first one is toluene, treatment with this reagent to form the first step product, and then the second step with ammonia, and finally oxidation to give the saccharine. So you have to remember this important multi-step process. So with this we will see the third compound in the list, that is the benzene hexachloride, BHC. This is the chemical structure of benzene hexachloride. So the benzene hexachloride contains, hexa means 6, right? Mono is 1, di is 2, tri 3, tetra 4, penta 5, and hexa is 6. So it is hexachloro, means 6 chlorine atom. 1, 2, 3, 4, 5, 6 are there. You can see in the structure. And it has this ring, okay, this 6-membered ring. So you have to see closely that even though it is written benzene, this is not actually the benzene. Benzene should contain what? Double bond, right? It should contain 3 double bonds, right? But it has no 3 double bonds, but still it is contained. The name is benzene because this preparation of this start from benzene, so it is called as benzene hexachloride. What is the molecular formula of this benzene hexachloride? So you can calculate easily, you can count just by counting, right? C6, 1, 2, 3, 4, 5, 6, Cl6, right? Cl6, this is Cl6, 6 carbon, 1, 2, 3, 4, 5, 6 carbon are there inside the ring, so this is 6. And hydrogen, even though it is missing, it is contain 1 nitrogen here, right? 1 nitrogen in each carbon. There is 1 nitrogen here, there is 1 nitrogen here, 1 nitrogen here, 1 nitrogen here, 1 nitrogen here, 1 nitrogen. So the molecular formula is C6H6Cl6. This is the molecular formula. So what is benzene hexachloride? It's an organochlorine compound, right? It is an organic compound because it is contain carbon and hydrogen. You should remember this. What is organic chemistry? We have looked into the introduction. Organic chemistry mainly contains carbon, hydrogen, right? So it is an organochlorine compound. So it is contains 6 chlorine. It is also known as, this BHC is also known as lindane. The commercial name of this is lindane. So it is used in horticulture, in the plant and the flower firm, for as a bug spray. It is used as a bug spray to kill the insects. The insect will destroy the plant or flower, so BHC is used to kill the bugs or insect. But important thing to note on is it is not good for the human health because it is a neurotoxin. It's a toxic to human. How it interacts? This BHC interacts with this gamma receptor, GABA receptor. GABA is a neurotransmitter. This one you will study in the medicinal chemistry about the neurotransmitter. So just remember this, BHC interacts with this neurotransmitter. That's why it is called as neurotoxin. Okay, it is toxic to the human health. So important points to note down is it's an organochlorine compound. Okay, it is used as a bug spray in horticulture. It's a neurotoxin. How it interacts into the human body? It interacts with the GABA receptors. Now let's see the physical properties of the BHC. BHC is a colorless crystalline white solid. It is a solid substance and it is very musty odor. So odor is it's a pungent odor, this one. It emits toxic hydrochloric gas, HCl gas. So it is very toxic if decomposed. So if it is, for example, if you eat the BHC, it will emit HCl and other chlorinated fumes due to decomposition. So it decompose to remove the HCl. I told it already, there is a nitrogen, right? Every carbon contain 1 nitrogen. So HCl can easily generate from here and decompose if you eat the BHC. Important properties, it does not react with water. So it is safe to handle in the water based condition. It will not dissolve in water, it will not react with water. So that is the important point also. It will not decompose, it will not destroy if you add water. So it is stable with water. These are some of the important physical properties of the benzene hexachloride. Let's see what are the uses of the BHC, benzene hexachloride. So benzene hexachloride is used to treat head lice. Okay, head lice. So the small insect present in the hairs, right? In the hairs. So if you use benzene hexachloride, it will destroy these head lice. So this small insects. And also it is used to treat the scabies. It's a skin condition. You see here in this picture, this little boy is having some rashes in the skin. So this is called as scabies. This also used to treat this head lice and scabies. So it is used as in the shampoo, right? Because the shampoo, if you use it, if it contains BHC, it will kill the head lice. So it is used in the shampoos also. to kill the head lice. BHC, also called as lindane, you have seen that lotion is used to treat the scabies. So this condition, this skin condition, BHC is used in the lotion so you can apply on the skin to treat the scabies. And finally, as we seen before, it is used to kill the bugs. So in the agriculture, this BHC is very helpful to kill the insects or bugs. So these are some of the important the uses of BHC. So these 4 important uses of BHC. Now let's see how to prepare the BHC. It is a very one-step reaction. So we have seen that in the case of the other the saccharine, we need multi-step, right? Multi-step synthesis needed to prepare the saccharine. But in the case of BHC, only one step is enough to make the compound, to make the BHC. So this is what is shown here. Benzene. How to prepare this? Benzene undergo hydrogenation. Hydrogenation means adding hydrogen. Okay, if you add, that will add hydrogen in the presence of chlorine. Okay, so in the presence of chlorine and UV light, so sunlight or UV light, if you artificial sunlight or direct UV light, if you can pass, there is no need of catalyst. There is no need of any metal or any other catalyst. You will get this benzene hexachloride compound. So here I have written like this wavy bond. This bond is written wavy because the chlorine can be up or down. Okay, for example, this ring structure is, for example, like in this plane. The chlorine can be, one chlorine can be here, one chlorine can be down, one chlorine can be up, down, up like that. So it can be any down or up position. So this is what I have shown here by using this wavy bond. This wavy bond is used to, in chemistry, it is used to depict whether the substitution or the chemical group is above or below. Okay. But you can see in the other structure I mentioned here, I forgot to mention this wedge structure, wedge bond, means the chlorine is up, and this dotted or this broken bond shows that chlorine is down. So there are 4 chlorine up in this structure and 2 chlorines are down. Okay, so but here this is not the case. You can, some chlorine are up, some chlorine down. There is no specific stereochemistry, but you can get the 4 chlorine up, 4 chlorine down by further processing. By further processing, you can get that structure. But anyway, I would like to mention here that the BHC can be prepared by treating benzene with chlorine and the UV light without any catalyst necessary to give this product. With this, we will move on to see the last the compound in the list, that is chloramine. See, chloramine is not a derivative of benzene. Okay, even though it is in the list, it is not a derivative of benzene. It is a simple amine. Okay, it is a simple amine. It's contain 2 NH2 as NH2. Okay, 2 H hydrogen and 1 chlorine atom attached to the nitrogen. Okay, so the 2 hydrogen is attached to the nitrogen, nitrogen, and 1 chlorine also attached. This is the chemical structure of chloramine. So what is the molecular formula? Simply count this NH2Cl. Okay, this is the molecular formula. So what is chloramine? So you can say that chloramine is a monochloro compound, right? It is a monochloroamine or monochloroamine or chloramine. It's called as chloramine. It's an inorganic compound. Okay, it has this chlorine, nitrogen and hydrogen. It's an inorganic compound with a molecular formula of NH2Cl. Let's see the physical properties of this chemical. Importantly, it is an yellow liquid. Okay, this chloramine is available as an yellow liquid, and it has very strong pungent odor. So all the amines are having very bad smell. So this is not an exception. So this also having a very strong pungent, nasty odor. It is very unstable to eat. We have seen Previously, the other compound like BHC and saccharine are stable to eat. BHC is not very stable to eat, but this is very unstable. Okay, when heated, it decomposes to nitrogen. Okay, the nitrogen will be removed from here. Chlorine is removed from HCl, and it can also form ammonium chloride. Okay, if two molecules can combine to give the ammonium chloride NH4Cl. Okay, so it is unstable to eat. So it is very careful handling this chloramine. And chloramine is soluble in water. So that is a good thing. We will see later why this property is very important for chloramine. Chloramine is soluble in water or miscible in water, whatever you can say. That means it mixes very well with water. It mixes excellent with water. So this mixing in water is very useful for chloramine. Why? Because it is used for drinking water. It is used as a disinfectant for drinking water. So there are many bacteria, virus present in the water, right? This, with the use of chloramine, it can kill the water. So the water purification is done by using chloramine. Chlorine also can be used, but this is more effective in killing the bacteria and virus, and also it is more safe compared to simple chlorine. And importantly, it is also used for sanitizing swimming pool. Okay, this is shown here, the swimming pool. So this water can be sanitized by adding some chloramine. So if you go to especially in this public pools where people and children are spending time to learn swimming or enjoying the water swimming, this chloramine is used for sanitizing this public swimming pool, or even at home swimming pool, hotels and etc. So these are the important properties of uses of chloramine. Finally, we will see the synthesis of this chloramine, which is very simple. Chloramine can be prepared by treating with ammonia gas. Okay, ammonia is available easily and very cheap, and chlorine gas. So you mix these two, you will get the chloramine. Okay, this double head arrow shows that it's an equilibrium reaction. It can go here, and if you this can also come back to the reactant. Okay, so if you react this chloramine plus ammonium chloride, you will get back the product, the reactant also. So it can easily prepared by this reaction. Okay, ammonia plus chlorine is chloramine, plus ammonium chloride also formed. Okay, ammonium chloride is solid and chloramine is yellow liquid. So you can easily separate, right? So you can easily separate and use for cleaning the disinfecting the water and swimming. So far we have finished the uses, and also with this we have finished all the topics of the unit 1. Okay, so benzene and its derivative is complete, and in the next class we will see the next chapter, that is the phenol. Okay, important properties of phenol, preparation of phenol, derivatives of phenol, etc. So with this I thank you all, and we will see in the next class about the second unit, that is about regarding phenols. Thank you.